Hello, this is Deep Thoughts with Deegan, and today I'm going to be talking about logarithms. Right? The basic logarithm function is just going to be the inverse of 10 to the x because it has a base 10. Right? Natural logarithm is, in my opinion, a lot better. It's just the inverse of e to the x. Right? So that's cool and all, but what if we had something different? What if we had, I don't know, what if we had to solve something that looks like something really stupid, like log pi. This is terrible. Log pi of e. Oh my god. This looks really painful, right? I hope it does. It looks painful to me. Well, there's a formula we can use for this, which is the change of base formula, which just looks like this. So the log base a of x, where a is a constant normally as a constant, is just going to equal to the natural log of x, whatever the input is, over the natural log of a, the base. So if I put this in, our input is e, and there we go. Our base is pi. So technically, this is equal to 1 over ln of pi. So it looks a little nicer. This is one of the ugliest functions that you could possibly come up with. This looks a lot nicer. Now, what do we do if the base is not a constant? Let's say, what do we do if we have a log base x? Let's say we have log base x of x. I'm just going to write it out the same. Input is x, and the base is also x. Now, for the natural log of x cannot equal 0. So really, this is actually just going to equal 1. However, x cannot equal 0. And we can just keep doing this. Like, here's another cool one that I thought of. Log base e to the x of, let's go, sine x. Right? Well, let's do it again. Natural log of sine x over natural log of e to the x is just going to equal natural log of sine x over x. See, it always looks nicer than that. And we can also do some other things with it in terms of calculus. So what I'm going to look at here is a harder problem that uses a lot of logarithms. Right? Logarithms are extremely useful. And sometimes we can use them in ways to fix other things. Right? So I'm going to actually have a problem that's going to be log base x to the x of, I'll just do x. Okay. So how might you do this? Now, you could do, well, actually you can't. You can't use the normal log rule. I don't think so. But I'm just going to rewrite this, saying we're now looking for the derivative with respect to x of ln of x over ln of x to the x. Now with our logarithm rules, we know that the logarithm of a to the b, where b is power, is equal to b ln a. So I can take this down here, and now we're looking at the natural log of x, derivative of the natural log of x, over x natural log of x. Actually, this is looking pretty nice, right? For something that looks so wrong over here, this is looking pretty nice. So now I can cancel these out. Now remember, if I'm canceling them out, I have to figure out where they're equal to 0 or undefined, because if they're equal to that, then this can't be true. And the only situation where the natural log of x is equal to 0 or undefined is where x is less than or equal to 0. So I'm going to write it this way. X just has to be greater than or equal to 0. Okay, so now this is going to become, it's a little all over the place, derivative with respect to x of 1 over x, which is just power rule. Right, so now I'm just going to apply the power rule. So we're going to end up with negative, because we take that out, negative 1 over x squared. And the only limitation here is that x has to be greater than 0. So you see, something that looks as horrifying as this just becomes this, right? So you can do this with any function. It's just, it'll become chain rule. And sometimes, if you're not lucky, quotient rule. But it works, and I think that's pretty cool. So that'll be the end of this video, and thank you for watching. I'll see you next time. This was Deep Thoughts with Deegan.